Great, so welcome back, and this is question 94, and it's called Binary Tree Inorder Traversal. And so here it's an easy level question, and we want to do exactly what the title says, which is traverse a binary tree in order. And so what in order means is we look at this GIF here, and I'll just kind of restart it hopefully. You go to the leftmost node, you hit that node, you recurse upwards, and then you go right, and so forth. And so when you actually recurse upwards and you go right, you actually continue going leftwards until you hit its leaf node, and recurse upwards, and so forth. So what that really is left, current, and then right. And so this is referring to the actual node itself. So we go to the leftmost node, and then once we go as far left as possible, we go to the current node, and if we can go right, then we go right, and so forth. So it might be worthwhile just quickly looking at and reviewing that traversal before you actually implement it, but assuming that you know it, we'll go ahead and implement it now. So what we'll do is, this is actually a good hint to use an array list, obviously, so we'll start with that, and it's of type integer, and we'll just call this output. And so now we'll just return that at the very end. And so what that output is essentially the output of the values as we traverse it in order. And so here we go, we can't go any more left, so we just stay at the current node, and then we go right. But when we go right, we want to go all the way to the leftmost node, which is N3, which is our current node. We can't go right, so then we go upwards, and you can't go right here, and so you just go to our current node. And so that's how we get 1, 3, 2. And so that's exactly our output. So now what we want to make use of is actually a stack, and it'll be of type tree node. And so as we're traversing our tree, we're going to be adding to our stack, and then when we can't go any further left, we'll just pop off our stack and then check the right node. And so what that looks like is we'll make use of a while loop. Actually, two of them will be a nested while loop. But first, what we want to do is have a pointer to our nodes here. And so initially, just be pointing to our root node. And so in our while condition, we'll just say while our node is not null or our stack isn't empty. And so although it is empty in this case, initially, at least we know that our node won't be null. And if it is null, well, that handles that first case of, okay, if it's null, just return an empty output. So inside of this, we're going to have another while loop. We're just going to say while our node isn't null, we're going to traverse left. So this is a traverse as left as possible. And so what that looks like is we're just going to say node is equal to our left node. Oh, we want to do that after we add our node to our stack. So we say stack.add the node, and then we traverse left. And so what that looks like is we're going as left as possible, and once we go as left as we can, then we we're constantly adding to our stack. We start here, we add to our stack, add that to our stack, that to our stack, and so forth. And so at the top of our stack will be the leftmost node, and then the second leftmost node, and so forth. And so we'll then want to pop this off our stack, and then add that value to our list, and then recurse upwards. So what that looks like is then we want to say, okay, we want to set our node equal to the top of our stack, which we pop off. And then we want to add that value to our array. So that looks like output.add the value of our node. And then simply we want to look to the right because we've traversed as left as possible. Then we grab the current node, and then we look if we can go right. So we say node is equal to our right node. So let's go ahead and run that and just see if there's any errors. Doesn't look like it. And success. So let's just quickly review that again. So what we have is we look at, okay, we want to output an array list. We just return that at the very end. And we want to make use of a stack, and that's very popular for these traversals to make use of. And so it's just going to be of type tree node. And so as we traverse our tree, we're constantly adding to our stack until we hit the leftmost node. That's then the current node. And so we then add that value to our array, pop it off our stack, and then we start looking at what's at the top of our stack. We can't go any more left because we already went as left as possible. And so then we just we add that value and we pop it off our stack, and then we look at the rightmost node, and you can't traverse any more left. And so we just pop that off our stack and so forth. So yeah, I hope that explanation helped, and good luck with the rest of your algorithms. Thank you.